Unit 2. Electricity. What is electricity? Electricity is the movement of electrons through a substance. What are the different types of electricity? There is current electricity, which is the continuous flow of electrons around a controlled path, while static electricity is electrostatic charge that once established does not move. The subatomic particles are electrons, which have a negative charge and are in energy levels. Protons have a positive charge. They are in the nucleus. Neutrons have a neutral charge and are in the nucleus. Protons do not move, and electrons do move. Protons do not move because they are in the nucleus, and electrons do because they are in energy level, farthest away from the attractive force. To gain a charge, a substance must gain or lose electrons. If you gain electrons, you get a negative charge. If you lose electrons, you get a positive charge. Friction. Charging by friction. As long as there is friction between two materials, electrons will move from one material to another. One will end up positive and the other will end up negative. The law of electric charges is that like charges repel, opposite charges attract, and a neutral and a charged object attract. How objects get charged by friction is that two objects will rub together. The one with the more attractive force that will attract more electrons will gain the loose electrons from the other object. You must have two objects with different charges. There must be contact. The more negative flows to the less active. It occurs when two objects with different charges, I dot E, negative, positive that is more positive than positive. When the objects touch, electrons will flow from the more negative to the less negative. For example, touching doorknobs. Charging by induction. One object must be neutral and the other must be non-neutral. The non-neutral will the non-neutral's charge / electrons will rearrange, either being repelled or attracted by the positive or negative charge in the other object. Some examples is a balloon to a wall. Conductors are materials that allow the flow of electrons, while insulators are ones that prevent or obscure the flow of electrons. Conductors are usually metals, and insulators are usually nonmetals. Discharging. The four different ways that static charges can be discharged. The different ways are grounding, where electrons are transferred from a charged object to the earth. The earth can take the electrons in because the earth is so big it's effectively neutralized. The other way is moisture. The moisture in the air eventually takes all the electrons away from the charged object. Eventually, the object will be discharged. A point. When an object has a pointed shape, electrons are able to escape or add at the point easily. A spark. After a certain amount of charge has been accumulated, an electron can jump even across an insulator to discharge. Uses of static electricity. You've got the electrostatic paint sprayer. Paint has a positive charge and the door has a negative. They then attract. The paint repels itself, giving an even coat and being attracted to the door, leaving less residue. Electrostatic precipitator. Smoke floats up and the extra particles rub against the sides of the tunnel. There are two metal plates that have a positive charge attracting the extra particles. The reason static electricity is dangerous is because a lot of the objects are flammable and it is easy for an object to discharge this spark. For example, a piece of core going down a chute. The piece of corn can rub against it, gaining a negative or positive charge, accumulating enough for it to create a spark, which can then cause anything in the barn or in the factory that is flammable to ignite. What is current electricity? Current electricity is the continuous flow through a given path. A complete circuit is required for electricity to flow because electrons or energy can't completely flow to the other side if it isn't complete. The important parts of a circuit is the load, which is whatever you're powering, the energy source, like a battery, the switch, what can turn and complete and turn off, control the circuit, and conducting wire, the path that electrons take. Electric current. Electric current is the rate of which electrons flow past a given point. We use an ammeter to measure it. It is measured in amps or coulombs per second. In a series, the current is consistent because there's only one path, and in a parallel, the current is split through each pathway because there are multiple pathways. Voltage is the amount of electrical energy in the electrons. The units are in volts, and they are joules per coulomb. You measure voltage with a voltmeter, which measures the potential difference, which is why voltage can also be called the potential difference, from one point to the other, to measure the voltage. Voltage in a series circuit is shared among all the loads because there's one pathway. Voltage in a parallel circuit, each path gains the full amount of voltage. Resistance. Resistance is the obstruction of the flow of electrons. The units is in ohms, the little omega symbol. The formula is voltage equals current times resistance. In series, resistance is equal to the sum of resistance in individual loads because it's one path. In parallel, the resistance is measured through each pathway. Each path is measured separately. So, the sum of all the resistance in an individual branch. An ohmic resistor has a linear relationship. The increasing number of loads on current in series, by adding more loads, the current will decrease because you're increasing the resistance, which in the relationship, the ratio of voltage equals current times resistance, decreases the current. In parallel, as you add loads, you're increasing the current because you increase the number of pathways, which get the full current. The 9 different types of energies are potential, which is chemical, nuclear, elastic, gravitational, electrical, and elastic. Again, chemical, nuclear, gravitational, electrical, and elastic. For action, you have kinetic, light, heat, and sound. For writing energy transformation, you'd write the energy in, arrow, the energy out. For example, TV, you'd write electrical, arrow, light, sound, and heat. You should be able to describe the different ways that energy is created. Hydroelectricity. It uses gravitational potential energy to kinetic. It is renewable. How it works is water falls, which turns a turbine. The advantages is that it's renewable and it's inexpensive and can control floods. The disadvantages is that not everywhere has a strong water and there's a limited amount. Fossil fuels, the energy is chemical. It is non-renewable. How it works is you burn the fossil fuels, which then heats up water, which then steams and compressed to turn turbines. The advantages are we have technology based around it already, and we can use it to easily adjust to changes. The disadvantages are that it is non-renewable, so greenhouse gases go to climate change and they're hazardous. Biomass, initial energy in, is chemical. It is renewable. How it works is biomass, decaying waste of plants and animals, decay, creating methane. We then burn the methane to create water, heat water, which then turns turbines. The advantages are that it's renewable. The disadvantages are that it's methane, so it continues to add to climate change. Nuclear, chemical, non-renewable. How it works. How it works is you have atoms, which are usually heavy atoms, are split, creating a chain reaction. This energy is used to heat water, which spins turbines. It's inexpensive and it can create a whole bunch of electricity from a very small amount of fuel. Disadvantages are that it's very hazardous and can poison many environments if it leaks. Geothermal. Its initial energy is heat. It is renewable. How it works is energy from the earth is used to heat water, which turns turbines. Disadvantages are that it's costly and not many places have enough geothermal energy. Advantages are that it's renewable and does not release greenhouse gases. Solar initial energy is light. Light energy enters two metal plates in electricity conducting solution. Advantages is that it's a great source to power small gadgets like calculators. It's useful in remote areas. Disadvantages are that it's not useful for powering big areas and it's quite expensive. Wind, it's kinetic, renewable. How it works, wind turns turbines. Advantages, it does not produce greenhouse gases. Farmers can still farm around that area. Disadvantages are that it's not consistent. It presents the issue with bird migration patterns. The last one is tidal. Its initial energy is gravitational and kinetic. It's renewable. How it works, tidal energy using kinetic energy spins turbines. Advantages, tides are predictable. It's once built, it's cheap. Disadvantages, it greatly disturbs sea wildlife. Only a few areas have enough power with tidal energy to do it. Efficiency. How do we determine the efficiency of an object? The formula is efficiency equals useful energy divided by total energy in times 100. Electricity is important because it is easy to transport and transform. Electricity is the transportation and transformation of energy. First, it's important because electrical energy is very easy to transport to different locations through wires and other such things. It's also good because we can transform any other energies we can transform electrical energy into any other type of energy we need, like heat. And it's also easy to make. Finally, we have power. Power is the rate at which they transform/use electrical energy. 1 watt equals 1,000 kilowatts. 1 kilowatt equals 1,000 watts. 1 watt equals joules, 1 joule per second. The two formulas for power is power equals current times voltage. The second one is E equals P times time, which gives you kilowatt hours. E equals P times T is energy transformed by power rating of, or the length of time for a load. Hour consumption in the home is measured by kilowatt hours because it's the number of kilowatts that are produced per hour. It's not measured in joules because it's too many joules to write.